Oh, hi there. We're glad you're watching one of our virtual lunch presentations. We have a lot of good information that we've been accumulating over the past several years, and we invite you to look down just below here and hit the subscribe button, and the little bell will give you a reminder of when our next presentation is published here on the YouTube channel. Thanks for your support. Appreciate it. And I'm really glad that we have Clark Novak with us today. Clark has had lots of experience in studio equipment. And when you talk about his pedigree from Pacific Recording, Axia, Lavo, I can't think of anybody that is more able to talk from a variety of equipment and setups as Clark. So Clark is going to talk to us a little bit about studio, conversions to digital, some of the problems, some of the tips, and he's got some answers if you've got questions. So, Clark, over to you, Red Leader.
All right. Thank you very much, Barry, and thanks for inviting me today. I appreciate the opportunity to see everybody and spend a little time. So I've prepared a short presentation. Hopefully, it will be short, and then we'll take questions afterwards. So let's go back to the very beginning. In the beginning, there was analog, and the engineers heard the sine wave, and it was good. The big problem with analog was that it required so much infrastructure. I mean, take a look at some of the beauties in the photo here. We're talking forklift installations, right? Of course, RF takes up a lot of space. But even on the studio side, I/O really consumes a lot of real estate as well. All of you will no doubt fondly remember the many hours spent installing and documenting these little beauties, or perhaps tracing circuits because the guy before you hadn't bothered to document anything whatsoever. When AES-3 came around, it solved a lot of audio quality problems, but it really didn't do much for the rack space and wiring issues. A to D converters were pretty much just as bulky as the analog input panels and patch bays that they replaced, and they took almost the same amount of cabling too. So finally, around 2003, audio over IP arrived, and it worked a big change on the old infrastructure models. It reduced cabling quite a lot, and it gave everybody on the planet a routing switcher, essentially. But it was still pretty bulky and pretty power hungry, too. The photo here is an early Axia setup. What you're seeing there represents 16 I/O and 1 console power supply, and ample ventilation space as well. AoIP systems have slimmed down quite a lot since then, but they still consume an awful lot of space, either in studio racks, if your system is distributed, or in TOCs when you've got a centralized setup. And as you know, space is at a premium these days. Engineering gets less and less real estate when facilities move or combine. So the question is, how do you handle it when you've got this much space and you're used to it, and suddenly management comes down the hall and tells you that very shortly you're going to have this much space instead? You might wish for one of these to solve your problem, but sadly, Whammo is long out of business. Luckily, manufacturers have recognized the need for more density in the rack and have been working on downsizing I/O for a while now. Axia's X node is a very compact 4 I/O device. You can stick 2 of these side by side in 1 rack space. Wheatstone's blades are 8x8 devices with a little bit of DSP and mixing built in as well. And if you happen to be a Dante fan, the latest Focusrite units get 16x16, and Audio Science has recently announced a 32x32 input device as well. But that's about the limit, and it's still not really enough density to make a real dent in rack space requirements. So with this in mind, let me introduce PowerCore, which is an IP audio I/O and DSP node, which uses the Ravenna protocol, which is AES-67 compatible. This is a 1RU device like the others we looked at, but instead of only 8 or 16 channels of I/O, PowerCore has a capacity of several hundred audio channels. How is this possible? Well, it's designed to be as dense as it could possibly be and incorporate as many functions as possible into the smallest amount of space. It's also a software-defined hardware device, which means that there are multiple ways it can be configured to balance cost and function and make it as versatile as possible. So PowerCore has 8 rear panel slots that you can load up a la carte with cards to accommodate microphone audio, line inputs, AES-3, a bunch of things. If you just put analog and AES cards in it, it can accommodate 64 I/O connections. And we'll take a look at the individual cards in a moment. On the front panel, you'll see there's 4 AES-67 ports on SFP that provide 128 channels of bidirectional audio and dual redundant operation. There are also 4 MADI ports with a total of 256 signals and a D-sub connector for 8 GPIO, which are opto-coupled silent CMOS relays, all the good stuff there. And then we finish off with separate CAN and serial ports for remote control and word clock for sync. Tie that into your house system. So let's take a look at the optional that we have for I/O cards. There are 9 plug-in cards available at the moment. The first is the mic line card. This is a dual-purpose card with studio-grade preamps and switchable phantom power. It has 8 inputs, and you can switch off the preamps and use the line inputs as line inputs if you don't have 8 mics or don't need that many mic inputs. This is the AES-3 card, 4 stereo in, 4 stereo out connections, all bit transparent. There is a second version of this card that's for stations that need to interchange signals with video equipment. This has many BNC connectors instead of the D-sub. All the inputs have sample rate converters on them. It's also bit transparent, and it works with Dolby E sources. I should mention at this point that PowerCore itself is SMPTE 2110 compliant, which means that it will speak to the video gear in your rack very nicely and exchange audio back and forth without much hassle at all. For pure analog input, excuse me, there's a line in card with 8 mono or 4 stereo inputs. And if you need to convert AoIP signals back to analog, line out card supplies 8 mono, 4 stereo channels. There's a nifty little thing that's meant specifically for studios. This is a studio I/O card, and it has 2 mic line ins, 2 line outs for monitor speakers, and 2 dedicated headphone feed outputs, perfect for studio console installations. Finally, there are a couple specialty cards. If you happen to have some pro audio gear with Dante in it, in your newsroom or production rooms, you can now connect your Dante network to your AoIP network using the Dante card. And finally, a single port and dual port MADI card, which are again useful if you're working alongside a baseband TV environment. I should mention soon there's going to be a 10th card. We'll be announcing this at IBC, which is an 8X GPIO card, which lets you expand your machine control options a bit more. So you can see that there's an awful lot of I/O out capacity packed into a PowerCore, but because we were talking about density and combining functions, this is not all it can do. PowerCore is also the engine that powers Lavo mixing consoles. So it has a built-in routing matrix up to 1920 squared cross points. There are 96 channels of DSP that you can use for EQ, de-essing, dynamics with gating, expansion, compression, limiting, all the good stuff. Up to 80 summing buses that you can use for custom mixes, and you can apply DSP to these as well. And all of this can be customized to balance cost with performance. PowerCore, like I mentioned, is a software-defined hardware device. So there are 5 different tiered license packages that let you configure it as anything from a pure I/O device that sits on the edge of your network to a full-on mixing engine that at its maximum is capable of powering up to 4 average-sized mixing consoles at the same time. So you're probably thinking, this is interesting. I might be able to use this to consolidate some rack space and I/O. So you've got your own ideas. I have a few of my own. This is a small example of how a power core at its very base level saves space and eliminates complexity in a rack room. Another system would require 7 RU of rack space to house the same amount of mic line and AES3 inputs. Plus, you get MADI to AoIP conversion for free and nearly 100 channels of DSP processing to boot, all in 1 RU. And if you multiply that by 2 or 3 studios, you can see that you're freeing up a whole lot of space in the rack room with this single device. Here's another interesting application. We mentioned all that DSP that's built in. So in addition to I/O conversion, you can put that DSP to work as a whole facility EQ or dynamics engine. You put a power core on your network and you have enough processing to apply to any audio input that needs it. You could DS all your microphones in the entire facility. You could EQ every mixed minus. By the way, there's 32 of those built in. You could expand it up to 64. You could even sweeten the on-air feeds before they go to the STL if you wanted to do that. All of this is administered by a connected PC with a secure login. And so you can do it from your office or from one of the studios or even from home if you've got a nailed up LAN connection. So that's an interesting idea as well. You probably know I wasn't going to finish without putting in a plug for our Diamond mixing console, so here comes that. This diagram illustrates a power core at the center of a 4-studio setup, providing I/O, DSP, mixing, and control for 4 mixers, 3 physical and 1 touchscreen. And this is using the MAX license, which doesn't mean max like maximum, but stands for multiple access, as in multiple consoles can access all the resources of this power core device simultaneously. So you can put a power core in your central rack and co-locate the shared I/O devices with it, and you're saving an incredible amount of space and cost by consolidating all of these functions and probably taking a bunch of rack devices out of the studios and putting them in the central core as well. So this is just a few ideas that this can reduce rack space requirements in today's radio facilities. And I won't say that PowerCore is the only device that is capable of this type of consolidation. There are other manufacturers working on the same type of thing as well. But at the moment, this is the densest I/O and processing device on the market at the time. And there are more things coming. I'll leave you with a little bit of teaser. Next month at IBC, we'll announce another new product related to this that will make this solution even more interesting, both from a cost per input and from an operability standpoint. But I am obviously sworn to secrecy, so I'll leave it to you to imagine what this might be, and we'll talk more about it at IBC. So that's my back of the napkin presentation. Thanks for allowing me to be here. And if you have any questions, I'll do my best to answer them. Just remember, I'm only a marketing guy, so please be gentle. And I'll open up the floor.
All right, we have 2 questions already in chat here. Bill wants to know if you have SFP or SFP plus.
That's a good question. I know that we have several different SFP options for copper and multimode fiber. Whether that works on the plus, I am not altogether certain. I'm sorry.
1 gig or 10 gig is the question.
1 gig for sure. I believe it's 10 gig as well, since we're migrating all of our new devices to that standard. I would have to check just to be certain.
David, I see you have a question up here.
Oh, great. So now I have to read my own questions.
No, I'll read it if you'd like.
Yeah, okay. It just, once we have everything running through one RU device, I'm thinking, yep, it's wonderful. It's clean. When its power supply fails, could two of these in a rack have been set up to auto fall over?
Yeah, absolutely. So everything we build is built with redundant operation in mind. So yeah, I mentioned the front panel ports, redundant network connections, redundant control connections, and then on the back panel, there's redundant power supplies. One is 110 volt or 120 volt auto switching line input, and then there's a DC power inlet that can be used adjacent and simultaneously to that. And then you can cross connect two of these devices so that they automatically fail over if one, for some reason, goes offline. So it's very highly redundant in terms of setup.
Clark, when you show what all these features add up to in the power core, now suppose you have a whole bunch of analog consoles in the station.
Mm-hmm.
They connect right through these cards, and you digitally connect them, and then you spit out analog at the back end.
Yeah, as a matter of fact, we've had quite a bit of success with this for people who are just starting to get their toes into the AoIP world. So they've got analog or digital consoles that they really don't want to replace just yet, but they want to migrate over to AoIP. So PowerCore can act as a bridge device for converting the back end over to networked operation while still retaining the existing console setup.
I remember when I got into broadcasting many centuries ago that the television station that the radio station was attached to had this huge room filled with racks, filled with equipment. And some of those racks, it would take 2 or 3 racks for one camera. And Hal, I imagine you remember some of that when they rebuilt it. They ended up with many, many fewer racks, especially with solid state gear. And we're reaching that point, as you call it, denseness. And that I think is good. But as David says, you want to make sure it's redundant.
Sorry, I was muted. Yeah, I agree absolutely. There's no reason in today's environment not to be have as much backup to your backup as you can possibly do. It's just, the belt and suspenders approach. It's always a good idea.
Now I'm going to raise the elephant in the room question, and that is, with all this A to D and D to A happening, how bad is the degradation of your audio?
Well, like I mentioned, we've gone to great lengths to keep the audio transparent. So everything uses, on the analog side, everything uses very high quality A to D converters. On the AES3 side, everything is bit transparent. It's studio grade quality for all of the conversions from the top down. And a lot of US broadcasters may not be familiar with the kind of clients we normally deal with. We're a German company, and we started out servicing German public radio stations, and they are extremely demanding in terms of audio quality. Not that US broadcasters are not. We certainly want everything to sound as good as possible, but when it comes to nailing down the minutia, I can say that we have an imperative at Lavo to make sure that all our ducks are in a row and everything sounds as perfect as it can possibly be.
I have a question.
Go ahead, Bill.
So I assume that it supports Ravenna and AES 67 probably, and
Yes.
any others? Dante, certainly, we see that. Livewire, whatever they're calling theirs these days. And is there a Rosetta Stone license so you can use this thing to translate between different linguistic sectors?
It's a very good question. So AES 67 is the backbone of all of these AoIP protocols. And like Lavo, like Axia and like Wheatstone, Lavo was a part of the X192 working group that defined the AES 67 standard. So all of those devices that speak AES 67 and are AES 67 compliant will be able to exchange audio one with another. So if you've got some WheatNet devices or you've got some LiveWire devices, you can plug them into any system that is based on AES 67. And usually it takes a little bit of configuration, setup, pushing a few virtual dip switches behind the scenes, but they will all speak to each other. So AES 67 really is that Rosetta Stone that you're speaking of.
I haven't been very religious about following all that, but it seemed that you could, so a lot of the underlying stuff was kind of before times came out of the IETF standards for audio, and then Axia fixed the timing issues, and so now we're downstream a bit and into AES 67, but we don't have things like GPIO transports. It doesn't sound like we've got source indexing, mnemonic source indexing across platforms. Is there any hope for a device like this to kind of like keep a table and say, oh, I know that multicast address belongs to this named thing, and when I see it and the input, I'm going to output a different way at the output to another protocol.
Yeah, that is the one thing that is lacking in the AES 67 standard. So there's no, as you note, there's no GPIO transport in AES 67. It's purely audio interchange. There have been some discussions and proposals for an additional standard that will address those things. I don't know what the status of that is, but these things usually move fairly slowly. I know that with our devices, once you import streams from a device that uses a different, basically that uses the AES 67 protocol to connect, that is now a named input in the Lavo system and can be shared and routed around the facility. I don't know how the other manufacturers handle it at this time.
Yeah, it seems like nobody's interested in the GPIO problem. It's just too easy.
Yeah, there's a few places where the manufacturers just really aren't interested in cooperating, unfortunately. We work with everybody as much as possible. We have installations where clients are using Wheatstone consoles with a Ravenna backbone to perform the routing switcher functions. We have Axia gear in some systems that coexist with other pieces of equipment, but there are ways to make that GPIO logic follow, but unfortunately at this point, it's not a built-in native thing.
Clark, I'm going to ask a question from the standpoint of folks that are just starting to put their feet in the water, so to speak. You mentioned there's 5 levels. Is this a yearly payment or a single payment? Is it something that a small station would perhaps acquire to begin a studio rebuild, or does it require a certain size before it becomes economical?
Yeah, so there's, as you mentioned, there's 5 different tiers, And these range from everything. So there's an edge license that configures the power core as a pure I/O device. There's a super audio node license, which retains all of that I/O processing, and then adds on some DSP for EQ and dynamics. There are then a couple of console licenses that are specifically meant for use in a studio with a console. One is a small console, one is a large console. There is forthcoming a 6th license, which will be an entry level, like maybe an 8 fader console that only uses 4 of the I/O cards. That will be a very economical point of entry. And then, as I mentioned, there's that max license that unlocks absolutely everything, and you can power 4 consoles with it. The nice thing about this, since it's all software defined, is that you don't have to purchase the most you're ever going to need. You can start small, and then down the road in a year or 2 years say, you know what, I need a bit more of this, and come back and do a license upgrade, which is just a software unlock. So you can really pay as you go, and no, it's not a yearly license. It's a single purchase.
Very good. Anyone else have a question for Clark on the power core or on A to D, D to A activity? I remember, goodness, this goes back a few years, but I worked at a certain consolidation company cluster here that was running profit. Oh, I've told you who it is. Never mind. The point that I'm getting to is that the way that it was wired when I got there was just incredible, because they'd come out of the studio, which was using a German digital console, and they would go, everything would go A to D, then it would come back D to A, then it would go into the audio processing, another A to D, and then come out D to A to go into the EAS. And they wondered why the sound was not crisp and clean at the end point. And I said, you've got to get rid of all these codecs, or come up with a system where the codecs are not going to fight each other. And I think that's one of the things Lavo has done from everything I've seen. Yes, they're mostly known in Europe for these huge consoles and public radio and TV. But as Clark is saying, bringing that technology now to where punch blocks become irrelevant and other ways of connecting equipment become important, I think it's amazing to consider getting rid of all the A to D and D to A problems and start to benefit from the technology.
And so many things are IP networked these days. So much of our peripheral devices, certainly our computers, our playout systems, our digital editors, all of those things are native IP devices. They can go right into the network and get distributed around the studios however you like. So as time goes on, I think the process of I/O conversion will become less and less needful as more devices become IP native.
Very good. Again, anyone have a question here? Dan wants to know, many pieces of equipment will only work on 44.1K or 48K, so bitrate conversions happen at each step. So that's also A to D, D to A. That's another conversion issue, isn't it?
Mm. Well, all of our input AES3 cards have sample rate converters on them. So they convert to a common sample rate and enter the AoIP network, and then everything is running at the same sample rate from there on out, and that removes a bunch of the falderall from that process as well.
Brian asks, if the punch blocks are now irrelevant, how do you get the signals onto the D connectors?
I should mention that all of those D subs that we were showing in the cards are all pinout compliant with what is that standard? It's an AES standard. Um, the HOSA makes a bunch of XLR breakout cables that match that standard.
There's Studio Hub
Yes,
to go to RJ45s.
right. So all of those things are standard compliant as well.
The D sub thing is a Tascam standard, but as you say, HOSA has those cables too. But I'm pretty sure Tascam is the standard, and that's what it looks like anyway.
I think you're correct.
The ADAT standard probably.
Likely.
Dan mentions also that the Axia Live Wire I/O is only 48K, but HD processing and satellite distribution is typically 44.1. So there's almost always an incompatibility to be dealt with.
I would have to look at my material sheet for specs. I believe our AS3 outputs are sample rate switchable, so you can define what's coming out of them, as well as automatic sample rate conversion going in.
I think 48 kilosample per second is kind of the default video thing, and we've all become captives of whatever video wants to do these days.
Certainly seems so.
All right. Any other questions? I'm going to have a question here, Clark. Nobody else got to it before me. You have this whole big field of Lavo squares in a moose.
We're from the Black Forest, so there's plenty of wildlife down there.
And one of them got on your background.
Yeah, that's exactly it.
Okay.
And can you do the fandango? Was it Scaramouche or Gatamoose or
Scaramouche?
Chuck makes the point here that we're talking about 48K and 44.1, and so many stations are busy with their 64 KBS MP3s, and that's another conflict.
Yeah, certainly is. I think any PD or music director that's putting a 64 kilobit compressed file on the air needs a good knock around the ears, but that's a different subject, I think.
Can you send the moose out for that?
We might be able to do that.
are you close to Transylvania? Maybe you could drive a stake through MP3.
There you go. Well, Fraunhofer's over in Germany.
Yeah.
Dan is back again. Dan, you're welcome to open your microphone if you'd like. He asks if the processor and I/O connections are centralized. Does that mean running lots of analog wires to the central engineering area? I always like the nodes in the studio.
Yeah, so PowerCore is set up so that you can do it either way. You can use it as an edge device. You can use it in the central rack. We're agnostic that way. And if you don't want to put a PowerCore in the studios, but you still want just I/O, we have several, we call them A-line devices, which are short for audio line, and they interface, there's basically AoIP stage boxes that interface analog and digital audio. There's no modularity to them. They are just what they are. You get so many analog and so many digital I/O per A-line device. Those can be used in the studio. But as I mentioned, when I showed the box under wraps, we have something coming that will address that and increase flexibility on the edge as well, so that you can still keep your processing in the central room and outsource all the edge I/O and conversion without spending a ton of money doing it.
Oh, David is back. He says, we make a pledge to minimize number of translations get the backbone standard soonest and refrain from changes until the output interface. At least good A to D conversions and good SRCs are better than perceptual codecs.
Hmm.
I think there's another question in there that I would like to
Go.
love to hear an answer about is Ravenna over internet slash leased digital services or Wi-Fi point to point or that kind of thing. What's the prognosis there? Will it work? Will it sort of work? Will it like stay away from it?
Well, I don't think any manufacturer is going to recommend running AoIP over Wi-Fi. There's just too much bandwidth requirement, and Wi-Fi itself, especially out in the field, if you're trying to connect, boy, are you going to have fun with that. So I think everybody recommends, at very least, a nailed up WAN or LAN connection, something with guaranteed bandwidth from the studio to the field, or the far end, or whatever other campus you might happen to be operating from. And everybody's very, everybody I've talked to lately is really exploring their options when it comes to remote operation and operating equipment from home. So I think there's two ways to do that. You can have a full-on studio setup in the field and then just exchange audio with the central office, or you can have a remote control interface for your studio gear that the operator in the field is working with. That requires much less bandwidth, but it does add a bit of latency to the control operation. So everything's a trade-off when you're talking remote. It's cost versus performance, and you really have to figure out which way is most tolerable for you.
So your soft consoles work well over networks?
Yes, absolutely. So in fact, our soft console is based on the power core with a software front end. We have a software package named VisTool, which is the basis for all of our touchscreen console operations. And so all the functions remain in the box, and the operator just is moving a UI. Did I answer your question? Because I may have gotten off track there.
Oh no, yeah, no, that was good. I just, if you have any idea about minimum recommended bit rates, maximum recommended latency, jitter issues.
Well, I think for any LAN connection, 10 gigabit is probably a safe bet. If you really want to make sure there's no problems whatsoever, forever and ever, amen, then 10 gig is great. 1 gig is the standard that we're based around for control and audio exchange, because nobody figures you're going to be sending 128 channels of bidirectional stereo audio down a LAN connection to a remote site. You may be sending 20 or 24 channels maximum for any given operational scenario. And a gigabit will certainly handle that. But if you're doing a full-on remote exchange of multiple channels of networked audio, you're going to want a bigger pipe.
Yeah, we're just putting in a new studio, and we don't have any copper between the studio and the engineering space. It's 12 strands of single mode fiber.
Mm-hmm. Well, it's interesting to see that that the newest switches in the marketplace, especially the ones that are most usable for AoIP, all have gigabit as the baseline. There's no more 100 base T. It's hard to find a switch with 100 base T ports these days. So everything is 110, and then the video side is pushing that even further, of course.
Very good. Very good. I know that Lavo is kind of a new company or brand name to many folks here in this country. And I've already mentioned, and you've mentioned their use in Europe. Anything else you'd like to add? Talk about the relay maybe for a moment?
Yeah, this is a, excuse me, a pretty interesting solution. I'm sorry, let me clear my throat. So relay is we call it the radio in a box. So this is a pretty cool thing. It's either a 4 or an 8 fader desktop mixer that works completely self-contained on a Windows PC. So there's no external devices needed in order to use relay. You simply install it on your computer. You use whatever devices are available to your Windows operating system, either internally or coming in through external I/O. You can stick USB devices on your computer and use those directly within the mixer, or any kind of programs on your computer that supply ASIO or WDM drivers can be loaded directly to faders. And this has proved very successful as either a remote solution when you're on the road and you just want to carry a laptop with you. There is an I/O device that goes along with it for situations like that called an on-air 4, and that provides professional level mic inputs and line level and AES3 ins and outs, a couple of each, so that you can interface with stuff in your remote box. But if you're using it in a studio situation where all of your devices are right there or in the box in the computer, there's no need for that additional I/O, and it's a very cost-effective solution. We even have stations, smaller stations, LPs, and some in countries where broadcasting is popular but money is not available, who are using this as their main on-air console. So that's quite an interesting option.
Well, we hope that folks will take a look at Lavo and see what that could help them, both with studio upgrades as well as improvements in their operation.
Thanks. I'd like to mention that we've got a very large support organization here, headquartered in the U.S. We've got offices in Los Angeles, New York, and Canada. And right now our team numbers a little over 50 people based in the U.S. for support and sales. So it's not like we're turning everything over to Germany for our North American clients.
Well, that's good to know, because one of the problems many of us who have worked with some of the European manufacturers, you can't always communicate easily with someone in Italian or German or French. So this is good. This is good to know.
Very good.
Clark, thank you so very much for being with us today. And we're not going to chase you away or anything like that, but we'll let you off the hook here.
Thanks very much for having me. Thanks, everybody.